There is a camera sitting on the moon right now. It has been there since 1972. It was placed there during the Apollo 16 mission, and it was built by a black scientist from Chicago who most people have never heard of. His name is Dr. George Carruthers, and what he created changed the way humanity sees the universe. Not metaphorically, literally. Before his invention, we were partially blind to the cosmos. There is an entire spectrum of light that the human eye cannot detect. Ultraviolet light. Stars, galaxies, nebulae, they all emit it. And for decades, scientists knew it was there, but had no reliable way to observe it from space. The atmosphere blocks ultraviolet radiation before it reaches the ground. So if you wanted to study the universe in ultraviolet, you had to get above the atmosphere. And to do that, you needed a camera that could survive the vacuum of space, the freezing temperatures, and the radiation, and still return clear, usable images. That camera did not exist yet. George Carruthers built it. He was born in 1939 in Cincinnati, Ohio, but grew up on the south side of Chicago. From the time he was a child, he was obsessed with space. He built his first telescope at 10 years old using cardboard tubes and mail-order lenses. He read every science fiction book and astronomy magazine he could find. He joined the Chicago Amateur Astronomers Association as a teenager, one of the few young black members in the group. The passion was genuine, and it was early. But passion alone does not get you to the moon. He earned a bachelor's degree in aeronautical engineering from the University of Illinois in 1961, then a master's degree, then a PhD in aeronautical and astronautical engineering in 1964. He joined the Naval Research Laboratory in Washington, D.C. shortly after graduating, and he spent the rest of his career there. While other scientists were chasing prestige and publicity, Carruthers quietly went to work solving one of the most difficult technical challenges in astrophysics. Ultraviolet astronomy was a young field. Scientists understood the theory. The technology was the problem. Ultraviolet light behaves differently than visible light. It requires different materials, different coatings, different detector designs. Carruthers spent years developing and refining a device called an ultraviolet camera and spectrograph. Yet the basic idea is this. He created an instrument that could capture images and data in the ultraviolet spectrum from outside the Earth's atmosphere in conditions no ordinary camera could survive. In 1969, he received his first patent. The device worked. It was not a concept or a prototype that sort of functioned in a lab. It was a real, functional instrument that produced real scientific results. And NASA took notice. When NASA was planning the Apollo 16 mission in 1972, they wanted to conduct serious science on the lunar surface, not just collect rocks, but actually use the moon as an observatory platform. The moon has no atmosphere, no atmospheric interference, no light pollution. From the surface of the moon, you can observe the universe with a clarity that is simply impossible from Earth. The Carruthers camera was exactly what they needed. He worked directly with NASA to design an instrument for the mission, the Far Ultraviolet Camera and Spectrograph. It weighed about 50 pounds and stood roughly 20 inches tall. It was mounted on a tripod on the lunar surface by astronaut John Young during the moonwalk. And then, from the surface of the moon, it captured over 200 images of Earth's atmosphere, of distant stars, of nebulae, of hydrogen distribution in space, images that had never been possible before. One of the most striking images it produced was of Earth itself. Seen in ultraviolet from the moon, the hydrogen surrounding our planet became visible. The atmosphere, that thin layer of gas that makes all life possible, glowed in a way no human eye had ever witnessed. And it was the first time scientists could clearly see Earth's geocorona, the outer hydrogen atmosphere. That image alone was scientifically significant. But the camera produced dozens of others, images that reshaped understanding of how stars form and how galaxies evolve. And that camera is still up there, sitting on the moon right now, left behind when the astronauts returned to Earth. It has been on the lunar surface for over 50 years. What is remarkable about Carruthers is not just what he built, but when and where he built it. This was the 1960s and early 1970s in America. Segregation had only legally ended a few years before. Black scientists faced institutional barriers that were not subtle. they were explicit. Access to certain universities was restricted. Access to certain research positions was limited. Yet the culture of American science was not welcoming to black researchers. And yet Carruthers navigated all of it, earned his credentials, joined a federal research laboratory, and produced work that ended up on the moon. He was awarded the NASA Exceptional Scientific Achievement Medal in 1972 for his work on Apollo 16. He was inducted into the National Inventors Hall of Fame in 2003. He received honorary doctorates and recognition from the Black Engineer of the Year Awards. But outside of scientific circles, his name remained largely unknown. Most Americans, even those who watched Apollo 16 on television, had no idea who built the camera sitting on the lunar surface during that moonwalk. That invisibility is not accidental. It reflects a pattern in how scientific credit gets distributed and who gets remembered. As the astronauts become famous, the engineers and scientists who build the tools they use are forgotten. And when those scientists are black, the forgetting tends to be more complete. George Carruthers spent many years after the Apollo 16 mission continuing his important scientific work. He focused on ultraviolet imaging and helped develop technology used in space shuttle missions. His research improved our understanding of comets, interstellar matter, and how galaxies are structured. Beyond science, Carruthers was deeply committed to education. He worked closely with students in Washington, D.C., especially black youth interested in science. He believed that more effort was needed to support and guide young black scientists. To achieve this, he created educational programs and personally mentored students in helping them build careers in science. Overall, Carruthers not only advanced space research, but also inspired and supported the next generation, ensuring that more diverse talent could succeed in scientific fields. He passed away in January 2020. He was 81 years old. His legacy is not abstract. It is physical. It is sitting on the surface of the moon, in the Sea of Descartes, exactly where astronaut John Young placed it in April 1972. No one has moved it. No one has retrieved it. It will likely remain there for thousands of years, a piece of human ingenuity left behind on another world. When we talk about the space race, we focus on rockets and astronauts. But the science, the actual understanding we gained, came from instruments, came from cameras, came from people like George Carruthers, who spent years in labs solving problems most people did not even know existed. The universe does not care about race. It does not discriminate about who gets to understand it. But the systems we build here on Earth do discriminate. And that means the history of science is full of people who contributed at the highest level and were never fully recognized for it. Carruthers is one of them. But recognition does not change what he did. The camera still worked. The images are still real. The science is still true. And the instrument is still on the moon. That is what the work means. This is 400 Plus, where we tell the stories that should have always been told. If this is the first time you heard the name George Carruthers, share this video. Well, because the next generation of scientists is watching, and they need to know what is possible. Subscribe, and we will keep bringing you the history that does not get taught in school, because these stories matter, and they deserve to be heard.